Okay, having seen the electrochemical series, now we move on to the electrolysis of lead bromide. That's the first compound that we are going to learn about. And when we come to lead bromide, all lead salts, okay, lead salts are insoluble in water. Except lead nitrate. Lead nitrate is soluble. Of course, lead chloride is soluble in hot water, but lead bromide is insoluble. Therefore, what's the other way of doing it? It is in the molten state. So that is why we can only do it in the molten or fused state. And the boiling point of this is 380 degrees. So that is the temperature we need to melt this lead bromide. Okay. Now coming to the crucible. So when you take the electrolytic cell, because we are heating it, we are using a crucible and it should withstand such a high temperature. Therefore, it is made of silica. Okay. So silica crucible makes up the electrolytic cell. And when you come to the electrodes, because the electrolyte, that is molten lead bromide, is there, which is reactive, therefore the electrodes are inert and it is made of graphite. Okay, so much for the apparatus. Now when you connect it and start doing this, first thing that happens is to dissociate. So it will break down. So that reaction we need to learn first. So how does it break down? Lead bromide, when it is heated, it will break down into lead ions and bromide ion. Now here there are two atoms, therefore we write 2 here. And we will not write 2 minus, but it is because it's monovalent, it can be written as Br minus and 2 atoms of bromide. Okay, that is dissociation reaction. Now, what are the ions present in this? There are only 2 because we are not adding water, we are not adding anything else. So, the ions present are lead ions and bromide ions. Okay. Now we move on to the reactions at cathode and anode. What happens at the cathode? What is happening here? According to the mechanism of electrolysis, metals or cations will move towards the cathode. So which one is going to move? Lead only, because that is the metal. This migrates to cathode. Okay, so this will migrate to cathode. And what happens according to our electrolysis definition? It will migrate to the cathode and become neutral atoms. That's what's the reaction happening at the cathode. How does it become neutral? When it is 2 plus, which means it is running short by 2 electrons. Therefore, it gains 2 electrons there and becomes lead metal. This lead metal is silvery gray. So, as the reaction goes on and on, slowly the cathode slowly becomes, it attains this silvery gray color. Okay, all right. Now, when we move to the reactions at the anode, what's the other ion that is present? Is bromide. So, bromide ion will lose 1 electron to give bromine, and it does not exist as a single atom. Therefore, we have Br2. Besides, there are two bromide ions. So we can write it this way also. When there are two bromide ions, we need two electrons. So that gives you 2Br, and that forms Br2. Now bromine at this temperature is gaseous in nature. So what happens? And the color of bromine is reddish brown fumes. It's reddish brown, and at that temperature it will only give rise to vapors and it will not be in the liquid form at all. Okay, so that becomes reddish brown. See, like this you will have fumes coming up. You can see the reddish brown fumes, and that is nothing but bromine vapors. Okay, so this is what happens in the electrolysis. So the product, the last one is the product. So what did you see there? At the cathode, the product formed is silvery gray lead metal. That is the product at the cathode. At the anode, you have reddish brown bromine vapors. So this is how electrolysis of lead bromide is carried out at a temperature of 380 degrees. So with this we finish this session. We will get back with the session of electrolysis of acidified water. So keep watching and enjoy and learn.